So we're just going to do some of this together, all right? And this, to me, this test is probably a little bit simpler than the last test. Students usually do better on this test than they did the first test. So you want to keep that in mind. Don't get overconfident, though. You know, look through stuff and study. All right, so let me go through some of these type of things. Let's do some of the multiple choice problems. Okay, if I ask for the order of the matrix, I'm just asking what's the size. So what's the size of that matrix?
4 by 2.
4 by 2. Okay, it's got 4 rows and it's got 2 columns. So you've got to know how to name a matrix. Okay, if you don't know how to do that, I don't know where you've been the last couple of weeks. Okay, so that's something that you definitely have to know how to do. Okay, the other thing I want you to be able to do is augmented matrix. So if I give you a system of equations, you want to be able to do the augmented matrix. So look over my answer choices, and what do you think? You think B?
B.
D? Is that what I'm, D as in dog? Is that what I'm hearing?
Yeah.
Okay. Yeah, because this would be, remember you have a missing term there and you have a missing term there. You got to account for the missing term. So that first row is 2082, second one 09432, and then 47246. So that definitely looks right. Yeah.
So for this one, when you would have to do that, putting that t variable in, you would choose z because they all have numbers there. Is that right?
No, not, well, this one, if you were going to solve this,
Right.
this is not even in reduced row echelon form.
Right.
So what you would do, if you had to solve this, you would go to your calculator, put it in reduced row echelon form to get the solution.
Right.
Okay, and then we'll talk about that in a little bit about, you know, if it's a row of zeros versus no solution and all that. Okay? All right, so this thing starts off pretty simple, I think. Okay, the next one is just opposite. I give you a augmented matrix. Which system does that match? What do you think? It looks like D. Okay, yeah, this is just giving you, remember you got a column for x1, and actually in this case, it's xyz. So it looks like that first one would be negative 3x minus 9y plus 3z equals 6. Then the next one's 2x plus 2y minus 4z equals 9. Okay, you can't go wrong with these problems. Okay, there's nothing to this. This is not the hard part of the section. Everybody with me? Okay. All right. Okay. Now let's see this one. Let's take a look at this then. So this is kind of what I tend to do on the multiple choice. Is just kind of quick things that you can do in your head. Okay. That is a matrix that's in reduced row echelon form. What's the answer? What do you think?
No solution.
That's no solution. How do you know it's no solution?
0 plus 0 doesn't.
There you go. Okay, it's all because of this. So you got to know that what that means is 0x1 plus 0x2 equals 3. That's impossible because that would be 0 plus 0 equals 3, and that's not true. Okay? What if it was 0, 0, 0? What would that tell you?
Infinite solution.
Infinite solutions. Okay, and we'll get to that in a minute, how you do the parameter t, because students a lot of times don't do that as well as I'd like them to do. All right, so that's how you would get the answer on that then. So you need to know that. Okay, other things, let's take a look at this one. So I've given you a matrix A, and I'm wanting you to tell me what 4A is. Well, what do? You multiply everything by 4. Now, you can do this in your head, so you just kind of multiply everything by 4. So negative 3 times 4 is negative 12. 1 times 4 is 4. 0 times 4 is 0. 2 times 4 is 8. So what does that look like? That looks like A, doesn't it? Okay, so again, on multiple choice part of the exam, I'm looking for just kind of simple things that you can process in your head. Okay? All right. Next thing is, we talked about this a lot last week. Now what I'm asking you to do is, if I give you a system, can you write this in a equation format? So what do you think on this one? Which one do you think is the right one?
C.
Let's see if you're right. C. Okay, yeah, that looks good. Okay, because you have your coefficient matrix. 4, 5, 1, negative 5. That's good. Then you have your variable matrix, the xy. Then you have what it's equal to. So that's it. Okay, so you want to know how to take a system and write it in the matrix equation format. Okay, like that. You're not solving. You're just seeing that you know how to write that in the equation. Okay, is that good? Okay, so study and you want to know how to do that. Okay, the next one I think is where it gets a little bit harder for students. Okay, so first of all, when you see a row of zeros, what does that tell you?
Infinite solution.
Infinite solutions. Now with this one, we're not going to just say infinite solutions, we're going to do the parameter. So pay attention to this. This sometimes students don't do so hot on. So the first equation is saying 1x1 minus 4x2 equals 10. That's what that's saying. The second equation just tells you that there's no solution. So what you have to do is, if it's infinite solutions, you have to work with this parameter t. So what you typically do in this case is let the second one equal to t. You could do it backwards, but if it's multiple choice, you're going to try to follow and figure out which solution it is. Okay, so I'm just going to say x2 is t. Okay, what do I do with that t?
Replace x2 every instance you see.
Right, okay, that thing is going to go there. Okay, so you're going to plug in the t there. All right, so what you're going to get is you're going to get x1 minus 4t equals 10. Now what do I do? You tell me what x1 is, right? So you solve this for x1. So you just need to get x1 by itself. So you would get x1 equals 4t plus 10. Now when you write your solution, there's two ways you write this. You could just, if you write those two things there, you're good. You could also write this as a point where you would just say the first one, which is 4t plus 10, and then t. Okay, so that looks like the correct answer on that one. And which one is that? Probably B. x1 is 4t plus 10, x2 is t. So that's how you do that. So you want to know that, and what you're looking for is the knowledge is the row of zeros is what tells you that you can parameterize that. And you just let t be the second variable in this case. Okay, and then x1 is in terms of t. Does that make sense? Yeah.
Will there be an example on here where there's three, like where there's x1, x2,
Yeah.
x3?
Yeah, we'll get to that. We'll get to that. Yeah, definitely. That's if it's two equations and two unknowns, a little bit simpler than if you have a third variable. But we'll do something like that. Okay. Okay. Now here's another thing. Let's see what we remember on this. Okay, we're going to figure out which one has an inverse. Okay, well, on this test, you can use your calculator. So you could actually put every one of those in your calculator and see if they have an inverse, but that'd take you forever. So let me just kind of see what you guys remember on this. What are some things that don't have an inverse? This is what stuff we were talking about last week.
Non-square matrix.
Non-square matrices. That's square, right? That's 2 by 2. Okay, that's good. That's square matrix. Is that square? No. Is that square? No. So you can immediately rule those two things out. The only matrices that are going to have inverses, they have to be square matrices. So now we're down to a 50-50 chance. What's the next one I've eliminated?
Row zeros.
Okay, you can't have a row of zeros or a column of zeros, okay? So you would also knock that one out, and then that would be the one that has an inverse. Now, the other thing that you got to check is you got to check this. You got to do the diagonals. So if you did -2 times 1, you would get -2. If you went the other way, you would get 3 times 4. Those things can't be equal. So if they are equal, then it can't have an inverse. So notice on this one, if you did 0 times -2, and then you did 0 times 4, they would both be 0. So you got to make sure if it's and this works if it's a 2 by 2 matrix, the diagonals can't be equal. Okay, so all I'm looking at that is make sure you study the guidelines behind when you have an inverse and when you don't. So it must be a square matrix, and and there's no rows or columns of zeros, and the diagonals can't be the same when you multiply them. So that's what you have to know on that. Okay? All right. Other things I like to kind of check you on is these are 4 multiplication problems. You want to just be able to tell which one is possible. So the way you do this is like this. What is the size of this first matrix right here? That's 2 rows, 1 column. What's the size of the second matrix?
2 by 2.
2 by 2. Is that possible?
No.
No, how do you know?
Just move it over.
Okay,
Upside down.
because those are different, right? The only time it's possible is if that and that are the same. So you could wipe that one out. That one's not possible. You can't do it. Okay? All right. How about the next one? Let's see. This is a 1 by 3. What's the other one?
3 by 1.
Is that possible?
Yes.
Yeah, so that's it. Okay? The rest of them wouldn't work. This would be a 1 row by 2 columns. This matrix would be a 3 row by 2 columns. So it's not possible because those are different. And then the next one, what is a 5? What size is that? That's 1 by 1. Okay. Then you'd have 2 by 2. So that's not possible either. So you need to know if you're given 2 matrix, if you can even multiply them or not. And then we'll focus a little bit on here on how to do that method in just a few minutes here. Okay, everybody with me on that okay? All right. Okay, how about 10? Now what we're doing on this is we're adding and subtracting. What do the matrices have to look like in order to add and subtract?
They have to be the same size.
They have to be exactly the same size, right? Okay, so which matrices are exactly the same size? That's the only one. That's the only one you could do, because if you did this problem, you would just do 0 minus 0.5, 1 minus 0.7, and so forth. So they have to be the same size for adding and subtracting. Okay, so that's the difference between determining if you can multiply versus if you can add or subtract. Okay, so that's what you got to know there. All right, everybody with me? Yeah, okay, all right. So these is kind of the basic things that we've learned how to do. And then here's one more question. So here is the matrix equation. We were talking about this, I think, last week. We spent a lot of time on this. When you solve this matrix equation, do you know which one's the right one? A. Okay, yeah, it's got the inverse in it. So this is something that you have to know, is when you solve this equation, a matrix equation, you always want the unknown to be by itself. Well, what you do is you do the inverse of that, and that inverse has to be on the left, and it has to be like that. It can't be in any other order, too. So that's what we learned, is that's the solution to a basic matrix equation. In that order, A inverse times B. Can't be the different order or it's wrong. Okay? So that's something that you want to study. The multiple choice part of this, and these are just examples of the kind of things that I would ask you. I change things around a little bit, and there may be a few different things on here, but this gives you a good idea of the basic things I want you to know. These are just kind of the knowledge level quick things. Okay? All right, now let's go through and we'll start reviewing the stuff that you have to do work on. So one of the things we learned how to do was when we were before we even learned about matrices, we learned about solving systems of equations with different methods. Okay, this is something, a basic thing I want you to know how to do. How do you tell if something is an answer to a system of equations? Plug it in, and what does it what has to happen? It has to work, but does it have to work in one of them, 2 of them? It's got to work in all of them, so you have to do that. So actually, all you got to do on this is see x is 6, that's the x value, y is -2. So you just see if it works or not. So you would just have to show that you do 3 times 6 minus -2 and see if that's 16. Okay, that would be 18, and that'd be plus 2. So that's not 16, so it doesn't work. Okay, you don't even have to bother checking the other equation because it has to work in both. So what you want to study on that is just make sure that the only way something is a solution is if it works in both of the equations at the same time. Okay? Okay, we want to go through a little bit of substitution method on here. So one thing that you'll see on your exam, you want to be able to do substitution. And these kind of problems, when you're doing this, you can easily check your answers on this first. So when you do substitution, you're plugging one equation into the other one. All right, let me ask you what you would probably do as your first step on this problem.
Get x by
Okay, get one of the variables by itself. Why would you want to solve for x?
So you can plug x into the equation.
Because there's nothing in front of it. That's the key. If you took the top equation and solved it for x, you would have fractions all over the place. You're more than welcome to do it that way if you want to, but you want to keep it simple, okay? So the best thing to do is just move that 5y to the other side so that x is by itself. So that would be the first step that you would want to do on that, is do this. So I'm just going to write down that equation, and I'm going to, in my head, I can just add 5 to both sides, so I get x equals 5y, okay? What do you do with that 5y? You plug it into the other equation. Good. So the second step is the first equation is 5x plus 2y equals negative 162. Okay? Well, this thing right here plugs in there. Okay? Because that goes in there because that's what x is, see. So what you're going to do is put the 5y in there, and then you can solve the equation. Now, if you get to that point on your paper, I don't think any of you would have much trouble doing this because this equation is pretty straightforward. Okay, so what you're going to have here is 25y plus 2y equals negative 162. You got like terms, so that would make 27y equals negative 162. Then you could divide both sides by 27. And you'd probably use your calculator on that. I'm not sure what that is, 6 or something maybe? Yeah. Probably a negative 6 would be my guess. So let's see, 162 divided by 27. Yeah, that's negative 6. Okay, so when you write your answer, you want to write your answer as a point. So we've got y. How do I find x?
Plug y back into x.
Let's plug it back into either equation. Now the easiest way is actually just to plug it in there. Because what we had was x equals 5y anyway, so we would get x equals 5 times negative 6, therefore we'd get negative 30. So the answer to that problem is that point, negative 30 minus 6. Okay, like that. Okay? All right, does that make sense? You guys have done that a lot on your homework. I've kind of helped a lot of you in this class with that substitution method. So you got to know what that is. And you want to make sure that you know how to use that method. You can't use another method on this problem if my directions say substitution. Okay? All right? What would you do on the next one? It's still substitution, so what would you do? Now, see, I've already got one equation solved for y, right? Okay? So this thing is y, so that thing is going to plug in. That whole thing right there is going to plug in right there. Okay, once you do the substitution, you'll have an equation with one variable. So you'll just say 5x plus y equals 53, but we know y is 28 minus 5x. Okay, then we'll kind of see what happens on that one. So if one of the equations is already solved for a variable, you just plug it in. All right, now let's see if we recognize what happens on this. All right, what happens when you put the like terms together on this problem? What do you see? I see something. What do you see? Okay, yeah, they cancel out. Okay, so that goes to 0, right? What are you left with? Where did the variables go? They disappeared. So what's the answer to this problem? No solution, right? Okay, see, that's a false statement. So anytime the variables cancel out and you get a false statement, then we would just say it's no solution. Okay, so that problem doesn't have a solution. You need to know the difference between the two. If that happens, the problem's very simple to work out. Okay? So does anybody need me to clarify substitution any further? Or okay. Just remember that you're plugging in, you're substituting one equation into the other. Okay, so that's one method we learned. Let's see, the next one, addition method. Now remember on addition, you're trying to add the equations together and you're wanting one of the variables to cancel out. Okay, so this is before we learned anything about matrices. So let's see what we remember on this. Okay, so it's your call. Okay, you can do this how you want to. Now, so if you want the x's to cancel out, if you want that to cancel out, if that's an 8, what would you like that to become? A negative 8, right? Or you can do it this way. If that's an 18, what would you like that to be?
Negative 18.
Negative 18. Take your pick. Let's get rid of the x's. So what do you need to do to that 2 so it becomes negative 8? Multiplied by negative 4, right? Okay, so both sides of that equation are going to get multiplied by negative 4. Okay, so that's what you would do here, is multiply that side by negative 4, and you multiply that side by negative 4. Okay, and then what you want to do is just, you can use your calculator to help you with this. That would be negative 8x. Okay, then I would have negative 4 times 18. I think that's minus 72y. And then if you do 112 times 4, you're multiplying 2 negatives, so that would be 448. And you don't want to do anything with the second equation. Okay, is everybody with me there? Okay, all right, what happens to the x's? They cross out. That's what we wanted to happen. Then if you do negative 72 plus 6, that's what, negative 66. So that's negative 66y. You can do 448 plus 14, just kind of double check stuff on your calculator. Okay, then you can divide both sides by negative 66. And then that would give you what the answer to y is. Okay, so I'll just take my calculator and do 462 divided by negative 66. And that gives negative 7. Okay, so when we write the answer, that's what the y value is, right? Okay, so that's how you start that. All right, what do you do to find x?
Plug it in.
Plug it in. Where? Either one, doesn't make any difference. So when you go to the next thing, pick an equation. It's your call. I'm going to pick the top one, 2x plus 18y equals negative 112. Okay, I know that y is negative 7, so I plug it in and I calculate. So that's 2x plus 18 times negative 7 equals negative 112. Okay, I'll do my calculator and do 18 times negative 7 is negative 126. Like that. Okay, and then it's pretty easy to solve from here. You can add 126 to both sides. That would give 2x. And if I do negative 112 plus 126, that gives 14. Okay, so what's x? 7. Okay. So that's kind of the methodology that you go through on addition. I call that addition or elimination. Okay? Does everybody understand the difference between substitution and elimination? Okay. All right, because I want you on your exam, I want you to show me that you know both methods. A person could check your answer. You know how to do matrices now. So you could either plug your answer into both equations, or you could put it in a matrix real fast, and probably within a minute you could verify that it's the right answer just by doing that on a matrix or just checking the answer. So much of what you're doing with systems are checkable. Okay. Everybody okay with what I'm doing there? Okay. You would definitely want to make sure you know how to do that. Okay, let's look at the graphing a little bit here. Okay, so with this one, I'm just going to run through a couple of situations with looking how to graph. So we have done tons of graphing in this class by now, of lines in particular. So what we want to do on this is we want to graph both of these equations, and we want to see where they intersect. Where they intersect is where the solution is. Okay, so what is the first equation? What's the slope?
1 over 2.
1/2. What are you going to do with the slope of a half?
Up 1 over 2.
Up 1, right 2. What's the y-intercept?
-1.
Okay, -1. Okay. Now when you do this, just be very careful about your graphing. You got a graphing calculator. You can check your graph on a calculator. So you would have y-intercept of -1. And then you have a slope of up 1 over 2. So I just go up 1 over 2. And one thing that you want to do on problems like this is keep doing the slope over and over again until you run out of room. Because you want to, I'm going to design these problems so that they're going to intersect at not at a fraction, but at a whole number. Okay, and then you can do the opposite of that. See, the opposite of that is down 1, left 2. Okay, so if you can go up and over, you can go down and over and do the same thing. Okay, so to me, you just want to get as many dots as you can on that first line. Okay, then you can connect that if you want to into a solid line. Okay, then we go to the next graph. Its slope is -1/2, so how do you count that out? -1/2.
Down one left.
That's down and right. Okay, rise over run, so that's going to be down 1 and then right 2. All right, your y-intercept is 5. Okay, so what you're going to do on this is you would start at 5, and then you would just start counting out the slope until you got to the other line. So I'm going to go down 1, right 2, down 1, right 2, down 1, right 2. Ah, there it is. Okay, so if you get all those dots on your paper, it should be pretty clear what that is. Okay, so what does that answer look like? 6.2. Okay, it's over 6, and it's up 2. So that would be the answer of that problem. Okay, like that. Okay, and you can do that. Now, the other thing is, you got a graphing calculator. You could, I mean, you don't have to. To me, it's just as easy to do this. But if you know how to use your graphing calculator, you can't go wrong, possibly, as long as you know how to put stuff in your calculator. So if I went to y1 and put in 1/2, and if I did it this way, that would have to be in parentheses, and then -1. And then if you did the second one, it'd be the same thing. You have to put that slope in parentheses or it ain't going to graph the right thing. I can assure you of that. So you could just put that in, and then you could do a standard window. And if you did that, once you get that put in, you can go zoom 6, and then that'll verify that you have the right graph, and you can pretty well tell by looking at this that it's right. I mean, if you went and traced at 6, well then there it is, 6.2. So your graphing calculator can absolutely 100% verify that you're doing this right. Okay, and that took me like less than a minute to even put that on the calculator and tell. Okay, so you're allowed to use a calculator, take advantage of that, see. Okay, all right, everybody feel okay with that? Okay, so we've looked at substitution, graphing, and elimination. And we're going to kind of a little bit here, get into the matrix part a little bit here today too. Okay, so this one we're also going to do graphically. What is the other possibility we learned on graphing? The one I just did, they intersected. What's the other thing we looked at?
They're parallel.
They're parallel. And if they're parallel, what does that tell you? There's no solution. Right, I suspect that's what this one is. So what you would want to do on this is you would want to solve each equation for y. Now, even though you'll be able to see their parallel once you solve for y, whoops, the other one was 5, wasn't it? I still want you to graph those. Okay, so you could move the x's, so you get y equals -2x plus 3 there, and you get y equals -2x plus 5. So how do you know they're parallel, by the way? Same slope, right. So you're going to know that if they have the same slope, then that's what's going to happen. You're going to automatically know there's no solution. Okay. So if you put this in, you would have your y-intercept would be 3. Your slope would be -2/1, which would tell you to go down 2, right 1. Okay. And so if we did this, we'd have a y-intercept of 3, and then we'd just go down 2, down 2, right 1. And you can do that as many times you want to. So that's the graph of the first one. The second line would be the same thing, except it's got a y-intercept of 5. So you would go up to 5. You would do the same thing. You would go down 2, right 1, and then you would see they're parallel. Okay, so that means the answer is no solution. Okay? All right, so you got to be solid on your graphing, and again, you can check that on your graphing calculator. Now you can tell that you've done the graphing on these things 100% correct. Take advantage of that. All right, so that kind of takes you through the system of equations without matrices. Yes?
So if the lines were same y-intercept and same slope, would it be infinite solution?
Yes, and we didn't really talk about that graphically, so you're not going to need to worry about that graphically, but that is what it would mean. You're going to look at that kind of situation in a matrix. Okay, so we just didn't go over the graphical part of that, but you're correct, that's what that would mean. Okay, this one is what we looked at last week. So when you're doing a system of inequalities, you have a shaded region. Okay, so I'll run through this. This is one of the last things that we learned how to do. So we have 2x plus 3y less than or equal to 6, x minus y greater than 3. So what you have to do is you have to graph those two lines and then figure out where the solution set is that you shade. So this one, the first thing you would do is just move the 2x. So you'd have 3y less than or equal to negative 2x plus 6, like that. Then you divide by 3. And when you do that, be sure that you're dividing everything by 3. So that's going to give you y is less than or equal to negative 2/3 x. 6 over 3 is going to be 2. Yes?
Now, if you divide it by negative, would you have to put the sign?
Yep. Got to change the sign. That's what's going to happen on the second one. Because you're going to move the x, then you're going to divide by -1. So you have to be aware of how the sign changes. Okay? All right, so let's graph this. So again, this one would have a y-intercept of 2. It would have a slope of negative 2 over 3, which would tell you that you're going to go down 2 and to the right 3. Okay, again, you could put this in your graphing calculator and make sure that you get the graph right if you wanted to. Okay, so what we're going to do on this is y-intercept is 2. So we do that, and then we're going to go from that y-intercept down 2 and to the right 3. Now let's see if we remember some of this stuff. Remember, when you do this problem, you're either going to have a solid line or a dashed line. Which would it be in this case? It'd be solid. How do you know? It's got the equal to bar, so that's a solid line. So that's important that you get that. So when you graph that line, you would have to make sure that that's solid. Okay? All right, here's the other thing you got to know. All right, that's less than. So where do I shade? Above or below if it's less than? What's logical? Below is smaller. So that means below. Now, you don't want to shade yet. You just want to make kind of a note to yourself. I was kind of showing you guys that you do something like that. You know I'm below that line. Okay, we've already eliminated that upper area right there. So what we have to do next is we have to take the second equation and we have to solve this for y and get it graphed. So what we would do here is you would move the x. So you have this. Now what would you have to do in your next step? Okay, what would that cause you to do, hopefully? Exactly, you got to change that sign. So that would become less than. That would be y. That would be x. That would be -3. Okay, just get everything right. All the signs are changing because you're dividing by -1. And what would happen on this one is this would be your y-intercept. The number in front would be 1 over 1. That would be your slope, which would tell you you're going up 1 and to the right 1 like that. Okay? So what you would want to do on this then is you would go down 3 like that. That'd be your y-intercept. Then you would go up 1, right 1. Okay? Now what do I do on this? Do I do dashed or solid? Dash. Do I go above or below when I shade? Below. Okay? You got to be careful because you change the sign. Change the sign, okay? So what you would do when you do this is you would do a dashed line for that. Then you can kind of write a little indicator to yourself as you're going to be below that there, okay? So what you are is when you determine where you shade, you're going to be below the red and below the dashed line like that. So the way I was kind of teaching you last time is I was just saying, okay, you got a 25% chance of getting it right. You're either there, or there. What do you think? You're in 4, right? Because you are below this line, but at the same time you're below that. So that puts you in this region. So you can kind of see where those arrows are coming together. So then what you would want to do is you just shade that. You know, take the side of your pencil or bring in a highlighter or whatever and shade. And that's the answer to the problem, is that shaded region. Okay, so if you're doing a system of inequalities, that's what you're doing. Okay. All right. double check your graphing. What, say it again? Yeah. Yeah, because what happens on this, see, they were both less than, right?
On negative slope. I got you.
Okay, so that means down below that and below this.
Okay.
That's why you're at 4. Okay? You got to pay attention to the inequality symbols as to where you shade. Okay? Okay, let's do one more here, and let's go over this, and then maybe the row operation. I'll just do that example. Now, just through a lot of stuff that we're looking at. So with this one, you got two things. You got x greater than or equal to 1, and you got y greater than or equal to -6. So you got to know how these lines go. How do you graph x equals 1? What kind of line is that? It's vertical. Okay, you got to know that. That goes through x. And again, this would be a solid line. So when you graph that, what you would do is you would go a solid line vertical through x equals 1. That's what that would mean. And since it's a greater than problem, well, that would be shade to the right. It's not, you're not doing up or down here, you're doing left or right. So what that would tell you is you're going to be in that area there before you get the final answer. Okay, same idea. Okay, how do you graph y equals -6? What kind of line is that? It goes this way. Okay, so this one would be the same thing. It would be a solid line, and it would be above because it's greater than. Okay, so what you would do on this is you would go down to -6, draw a solid line, and then you would be above. All right, so I'm just going to write kind of a little note to myself that I'm above that line right there. And if I number these, 1, 2, 3, 4, where would I be? I'd be in 1. Okay, so the final solution of this problem would be this whole region right here then. Okay, that's it. Now you got to know that and be able to recognize when you have a vertical and horizontal line and how that goes too, versus the ones where you have a slope and a y-intercept and that kind of thing like that. Okay, so that's kind of good examples of what you're going to do on system of equations. Let's do a row operation thing here and show you kind of how we're going to do this. We worked on this a lot in class, and a lot of you were having trouble with this, I thought. We're going to do this in 2 steps. So I've given you this matrix. Okay, what does this thing there mean? Row 1, double arrow, R2. What does that tell you? That tells you to do what? Swap them. That's a double arrow, right? Okay, it's supposed to be, I think. So what you would do is just the 4, -6 goes there. The 5, -3 goes there. You got to know the notation that I'm showing you on this, okay? Step 2, okay, I'm saying something goes into R2. So that means the new thing is going to go there, and it means nothing is going to change in the top row. Okay, that's what that means, okay? Now, what are you going to do with this? Okay, according to this, it says you're going to do -8 times row 1, then you're going to add row 2, and then you're going to get the answer, and that answer goes into row 2. You can do this in your head. It's best if you just write down what you have. Okay, now you've already switched the rows, so row 1 is now this. So what you're going to do is do -8 times that first row, and that's going to give you -40 plus 24, right? Then you're going to add row 2 to it, which is this stuff over here, 4 and -6. You're just going to add that together. So what this is telling you to do is multiply row 1 by -8, then add it to this row 2 here. So that would give you -36, and that would give you, what's that, 18. So you'd end up with that new matrix. Okay, I want you to know how to do row operations and be able to just do that. You're not going to ever have to do a Gauss-Jordan elimination of a matrix in this class, but you do have to know how to do row operations. Okay, so you need to know that that means switch and what that means. Okay, students don't do very well on that. I'm not sure why. Part of that is not really understanding what you're being asked to do, I think. Okay, but it's not that hard. Once you learn the language, it's easy to do. Okay, Okay, well, let's go ahead and let's take our break now, and